Welcome to the lecture series of Basic Electrical Engineering. Subject code is ECE 101. Today in this video lecture we will discuss the power factor and its importance and different power responses for AC circuits. Here we are having different powers, the active power, reactive power and apparent power. In this lecture, we will discuss all these things one by one in detail. First of all, we will discuss what is power factor and what is its importance in AC circuits. By definition, the power factor is the cosine of the angle between voltage and current phasor phi. When we are talking about the phasor diagram of any AC circuit, it is the cosine angle between the voltage and current. So cos phi, it is denoted by cos phi and it is called PF, the power factor. So as here in this we are having on x-axis we are having y and this is the current I. The angle between I and V is phi. So second, the ratio, power factor is the ratio of resistance to the impedance. Impedance is given by Z and cos phi is equals to ratio of resistance R upon Z. And the third definition is the power factor is the ratio of active power to the apparent power. Active power is denoted by P and apparent power is denoted by S. What do you mean by active power and apparent power? We will discuss in this lecture. Cos phi is equals to 1, it means maximum, 0 means minimum. Now we are considering all these things one by one in each case. For example, first we consider the case of resistance. In resistance, as in the previous video I have talked about the resistance, impedance and capacitance individually, their response in terms of current and voltages, and when they are in phase with each other, when they are leading or lagging. Please do refer that video lecture. So first of all, I am discussing resistance. We know in case of resistance, V is equals to Vm sin omega t and I is equals to Im sin omega t, and both voltage and current are in phase with each other, and cos phi is equals to the angle between the phi angle is 0, so cos phi is equals to 1. So whenever you ask the question what is the power factor of a resistance circuit, then the answer is the power factor is 1 or unity. It is always asked in the entrance exams. Then in the case of inductance, V is equals to Vm sin omega t as we know, and I is equals to Im sin omega t minus pi by 2, because there is a phase angle difference by 90 degree. So power factor is cos phi is minus pi by 2, so minus pi by 2 is 0, so power factor of the inductance is 0. And the third case, this is the phasor diagram of the inductance. This is voltage. On the x-axis we are having voltage and the current is lagging the voltage, and this is the 90 degree. So, or we can say voltage leads by 90 degree or the current is lagging the voltage, both are the same thing. So power factor PF is lagging I, and in the case of inductance, power factor is equals to 0. Then the next case is capacitance. In case of capacitance, V is equals to Vm sin omega t and I is equals to Im sin omega t plus pi by 2. So here phi is 90, cos 90 is equals to 0. So power factor in this case is also 0. So whether the case of inductance or capacitance, the power factor is 0. Here the phasor diagram is shown. The voltage is on x-axis and the leading current is shown, and it current leads by 90 degree in the case of capacitance. This shows the phasor diagram. So power factor is said to be leading or lagging by looking into the current. The current of the circuit tells us that whether the power factor is leading or lagging. Therefore, in case of inductance, the current is lagging and power factor is also lagging. But in the case of capacitor, the current is leading, so power factor is leading. As the case of the flow of the current according to the power factor becomes leading or lagging. Then active power. Active power is P. It is I VI cos phi, or I is equals to P upon cos phi. Greater conductor size, cos phi is low, means current is high. Poor efficiency, cos phi is equals to power factor is equals to low. So copper losses is equals to I square R. It also increases. This shows that in the case of if we are having the good conductor, conductor value is high, then the cos phi power factor is low. If we are having the poor efficiency, in that case also the power factor is low. Now the different powers in the case of AC circuits. We are having three powers in the case of AC circuits. The first one is apparent power, and it is denoted by S, and active power, it is denoted by P, and the reactive power, it is denoted by Q. To discuss all these powers, we are having few assumptions. Let's capital V is the RMS value of applied voltage, and capital I is the RMS current flowing in the AC circuit, and phi is the angle. This is the RMS value. Phi is the angle between voltage and current. For example, this is voltage, this is current, and this is the angle phi. So first we talk about the apparent power. It is the product of RMS value of the applied voltage and circuit current. It is also called wattless or idle power. S is equals to VI, and its units are volts ampere. Then active power. Active power is the power which is developed in the circuit resistance. P is equals to VI cos phi, and cos phi, as we know, it is R upon Z. We put the value this into here. V is equals to I into R upon Z, so it will become V upon Z into we put Z here, it will become V upon Z into I into R. V upon Z is equals to I, V upon Z is equals to I, so I into R, it will become P is equals to IR square, and the unit is watt. So the unit of active power is watt, and it is denoted by capital P. Then we are having next term, reactive power. It is the power which is developed in the circuit reactance. Q is equals to VI sin phi. VI, we put the value of sin phi. Sin phi is equals to X upon Z. So it will become VI into X upon Z. We can rewrite it as V upon Z into IX, and we know that this V upon Z is equals to I. so we replace it, it will become I into X, and reactive power Q is equals to IR square, I square X, and its unit is VAR. V is the volts, A is the ampere, and R is the reactive. So we talked about the three powers. First is the apparent power. It is denoted by S and it is equals to V into I. It is the total power of the circuit. P is V in VI cos phi. This is the power consumed by the resistance. Then Q is the VI cos sin phi. It is the power consumed by the inductance, and the units of Q is VAR, and the unit of P is watts, and the units of apparent power is VA, volt ampere. So these are the three powers. Now we find out the relationship between the three powers S, P and Q. This is P square plus Q square is equals to it is VI cos phi square plus I VI sin phi square. P square plus Q square is equals to, when we solve this VI common in both the equations, this VI common, and cos square phi plus sin square phi, and when this is equals to 1, so VI is S, so it will become S square into 1. Then we will become S square is equals to P square plus I square, or S is equals to under root P square plus Q square. So this is the relationship between the three powers. This is called power triangle. On the x-axis we are having P is equals to VI cos phi. On the y-axis, this is x-axis, we are having Pi cos phi. On the y-axis we are having Q is equals to VI sin phi, and we join these two, it will become S is equals to VI. So this is our active power, this is our reactive power, this is our apparent power. This is the relationship between the three powers. S square is equals to P square plus Q square, and S is equals to under root P square plus Q square. So this is all about the different powers. So in this lecture we talked about the power factor, which is denoted by cos phi. We talked about the sin phi. Then we talked about different powers, that is active power, reactive power and apparent power. So all these we will use in the coming lectures. With this this lecture is complete. Hope you like this lecture, and with this, thank you so much.